Okay, so let's look at some more examples of using trig to find angles inside of a triangle. So let's say I have a triangle here, and it's called triangle ABC, and let's say they want me to find the measure of angle A again. Okay, let's say they want us to find the measure of angle A. And the first thing I do then is that I start to label my triangle, and I do that according to angle A. So if this is angle A, here's my opposite side. Obviously, this is my hypotenuse, and this is my what? This is my adjacent side here. By the way, you should notice that this is a right triangle, and the numbers 4 and 5, a little red flag should go in your head. Those are the special numbers of the Pythagorean Theorem. So we know that this side here should be what? What should this side be here? If you guessed 3, you guessed correctly because the numbers 3, 4, 5 are one of the special numbers, set of numbers inside the Pythagorean theorem. So just know that. Okay, just a little refresher there. So they gave me this triangle here, and I have the opposite side is 4, and the hypotenuse is 5, and let's say they want us to find the measure of angle A, right? Well, the first thing is I have SOHCAHTOA, and my question is, well, in SOHCAHTOA, what are the which out of the three trig functions have the letter O for opposite and H, right? Well, it's going to be the what? It's going to be the sine function. The sine function has both the letters O and H, which means that the sine of A is going to help me find the measure of angle A. The sine of A is going to be the opposite of 4 over the hypotenuse of 5. So I'm going to just write that down here. The sine of A is equal to 4 over 5. Now, when I put it into my calculator and I get 4 over 5, I get 0.8, right? I get 0.8. And so now I want to find the angle. So when I want to find the angle, what do? I'm going to take the inverse function of A. I'm going to take the inverse function of A. So the inverse function of 0.8, I'm going to put that in my calculator here. So I have 0.8. I'm going to hit the shift button, and then I'm going to hit the sine button so I can get the inverse of the sine. That's going to give me 53.13. So when I do that, the measure of angle A is 53.13 degrees. Let's take a look at another example. Let's say I have a triangle here, and they want me to find the measure of angle A again. So notice here, here's my angle. Here's my triangle ABC. This time they gave me the adjacent side. They gave me the hypotenuse side. By the way, you should recognize the numbers 3 and 4. If this is 3 and 4, what's this number going to be here? This number should be what? Should be 4, right? So basically, we're dealing with the same triangle we were dealing with before. So here's the measure. They want me to find the measure of angle A, right? So take a look here. I don't have an opposite side, but they did give me the hypotenuse, and they did give me the adjacent side. So in SOHCAHTOA, which of the three trig functions has the hypotenuse and the adjacent side? Take a second to think about that. Well, if you said that it's the cosine function, you guessed correctly. The cosine function has the adjacent over the hypotenuse. So I'm going to say then that the cosine of angle A is equal to 3 adjacent over 5, the hypotenuse. When I put that into my calculator, 3 over 5 comes out to be 0.6. So great, I got the trig function. I have the trig ratio between these two sides. But I'm looking for the angle. So how do I find that? I have to take the inverse function of 0.6. I got to take the inverse function of 0.6. So I'm going to type in 0.6. I'm going to hit shift so I can get the inverse function of the cosine, and that's going to give me 53.13. Gives me 53.13. Now, are you surprised that both of these answers are the same? You shouldn't be, because in actuality, these two triangles are exactly the same two triangles. You know that the magic numbers for the Pythagorean theorem are 3, 4, and 5, right? This is 3, so we know that really if we did the Pythagorean theorem, this side would be 4. The only difference is that in this triangle, I gave you the hypotenuse and the adjacent side, so we had to use the sine function. And in this triangle, I gave you the hypotenuse, I'm sorry, I misspoke there. In this triangle, when we started the problem, I gave you the hypotenuse and the opposite side, which is why we use the sine function. O and H, gives me the sine function. Here, I gave you the hypotenuse and the adjacent, which is why I had to use the what? The cosine function. But look at that. It doesn't matter which two sides I gave you. The measure of angle A came out to be what? Exactly the same. Because the measure of an angle doesn't change simply because, I'm picking two different sides of the triangle. Let's take a look at the third example. Here is a third example. Here, again, you can see it's the same triangle, right? I have the sides. I took away the hypotenuse, and I gave you 3 and 4 as the two legs, right? So let's take a look here. They want to find the measure of angle A. So I label my triangle. Here's opposite. This is the hypotenuse. This is the adjacent side. What two letters did they give me? They gave me the O and the A. So out of SOHCAHTOA, which of the three trig functions has O and A? I hope you realize that it's the tangent function, right? Hope you realize it's the tangent function. So the tangent function is going to be opposite over adjacent. So the tangent of A is equal to the opposite of 4 over the adjacent of 3. So that comes out to 1.33 repeating. But I want to find the angle. So what do I have to do? I have to take the inverse function of 1.33 repeating. So when I do that, here, let me grab my calculator. Let me take 4 divided by 3. I get 1.3 repeating. And I want to find the inverse function of the tangent function, right? So shift, tangent, and what do I get? 53.13. So the measure of the triangle, the measure of angle A comes out to be 53.13 degrees. Now, let me ask you a question. If this is 90 degrees, and this is an angle A is 53.13 degrees, what's going to be the measure of angle B? What's going to be the measure of angle B? See if you can take a second to think about that. If this is 90 degrees and this is 53.13 degrees, what's going to be the measure of angle B? Well, if you remember, a triangle has 180 degrees, right? If I use up 90 degrees here, I'm going to subtract 90. That leaves me with another 90 degrees. And if I use up 53.13 degrees here, minus 53.13 degrees there, leaves me with 36.87 degrees. Which means then that the measure of angle B is 36.87 degrees. The measure of angle B is 36.87 degrees. But let's pretend for a second that I didn't know that. Let's pretend that I didn't know any of the information here and that I wanted to find the measure of angle B. Let's say that they asked me to use trigonometry using the measure of angle B. And remember, we know that angle B should be equal to what? 36.87 degrees. Well, here's my triangle B. And so now, since I'm looking for the measure of angle B is going to determine how I labeled my triangle. This is going to be the opposite side of angle B. Obviously, this is the hypotenuse, and obviously this is going to be my adjacent side. And so now I look at my triangle, and let's see here. They gave me the hypotenuse, and they gave me the adjacent side. So in SOHCAHTOA, which one has the hypotenuse, and which one has H, and which one has the A? Well, I hope you realize that that is the cosine function, the ka in SOHCAHTOA. So the cosine of B is going to be equal to 4 over 5 because the cosine is the adjacent over the hypotenuse, the adjacent A over the hypotenuse of 5. So 4 over 5 is equal to 0.8. Of course, I'm looking for the angle, so what am I going to do? I'm going to use the inverse function of 0.8. And when I do that, let's take a look here. What do I get? Let's take a look here. I got 0.8. I'm going to hit the shift button, and I'm going to hit the cosine button. And look at that. What do I get? 36.86 degrees or 0.87 degrees. Exactly what we said B was going to be. Okay? And if you look here, it doesn't matter how you do it. Let's say, for example, here, that I want to know the measure of angle B, and they only get they take away this side here, and they give me the opposite and the hypotenuse, right? Well, which one has O and H? It's going to be the sine function, so it's going to be 3 over 5. So again, I get the decimal. I take the inverse function, and what do I get? I get 36.87, just like before. Let's take a look at another example here. Let's say that they only give me these two sides here, right? Let's say we get these two sides here. Let's say, so now they want to find the measure of angle B. Well, this is my opposite side. Here's my adjacent. They don't give me the hypotenuse this time, so I have the letters O and A, which are going to force me to use the tangent function. So the tangent of B is going to be 34 degrees. That's going to give me a decimal of 0.75. I'm going to want to use the inverse function of 0.75, and when I do that, guess what I get again? 37.86. So really, I can find any angle of a triangle using trigonometry if I label the triangle depending upon what angle I'm looking for. Here I was looking for angle B. I labeled my triangle, and then the two numbers or the two letters that they give me in my labeling will tell me which one of the three trig functions I'm going to use. And if you look here, here's the 53.13 for angle A, plus the 36.87 plus angle B that we got, plus the 90 degrees for the right angle, and these two together equal 90, and 90 plus 90 equals to 180. So we know that the three trig functions do work. So if at any time you want